in the taxonomy.
Excuse me, the registration. I'm I forget it. Okay.
So, and all these were all lanceolata, and then they gave it a variety name. That was maybe easy, but it also created a lot of confusion. And these are all the names that you could find in the old classification that started with Agnanthes lanceolata. There's 94 names. I have to say, this is not only Europe. There are also Indian things and South African things and South American things. This is not only Europe. But then they decided we should split the genus Agnanthes in a large number of genera, and we all know Planothidium and Crenotia, Eucoconeis, Caraevia, Platessa, Psammotidium, Rosidium. All these genera have been separated from Agnanthes, and one of them was separated in 1996, so that's already 27 years ago, by Frank Round and Ludmila Bukhtiariova, and they called it Planothidium. And this is the original description of the genus Planothidium. I'm not going to read the description, especially not in Latin, although I think even the Latin might be easier for you Italian people than for other people. But the most important thing is that it has this spot, as you can see here in this picture 12, or here in this picture 7 and picture 8, you have this spot, but there are species that are lacking this spot. So what is the typical feature? The typical feature is usually these Planothidium species are strong, robust species. They have a lot of silica, and you can see that in your light microscope because it breaks the light very easily, and you can see actually the structure of a Planothidium very, very clearly. Some of these have a spot on the Rafeless valve, but not on the Rave valve. So be careful, it's only on one part of the valve. Sometimes it's just a print, like somebody pushes with his finger and made a print. But sometimes you can also see a line in the middle. I'll talk more about this line. What you also can see is that the striae in every Planothidium are very fat. The reason for that is if you look on the electron microscope, each stria is composed of several, both in Rafeless and Rave valve, of several small areolae. So it's not one row of areolae, it's 4, sometimes 5, sometimes 2, sometimes 1. But that means that you have very fat striae. This is just to show you how this, if you look in the electron microscope, these areolae are all covered individually by a nice small perforated hymen, but that's actually just for electron microscope and just to be complete about the genus Planothidium. But the most important feature, and that is something you really have to keep in mind, and you have to look for it because it helps you to identify your Planothidium, is that you have sometimes called a sinus, and a sinus is just a small depression made by a thumb. Take it like that. It's somebody who pushed with a thumb in the sample, in the valve, and left this small print. I deliberately show you the internal structure because on the external structure, you don't see this in the electron microscope. You only see in the electron microscope that there is a gap in the striae without striae. So you have a hyaline gap in the striae. There is a second group, and that's the group that has cavums, and it's like a cave. You have to think of a cave, and this is the cave entrance, but this cave entrance is sometimes not completely straight, but a little bit to the inside. And then you have this line here that I'm now going with my red dot. This line produces a thick line also in the light microscope. This is what is called cavum. Think of cave. Sinus, no cave, cavum, cave. And it's the shape of this cave, this cavum, that can help you in identify your species. For instance, look here, the first striae on both sides next of the cave is still open and not covered by the cave. In some species, it can be covered by the cave, and then you have a really broad cavum. It will be more clear when we develop the rest of the presentation, and I will tell you every time, look at the cave here, look the line, and so on. So the last years, more than 100 taxa are known, and a large of them have already been replaced to separate species or in synonymy with other species, but there was still a huge need for a good cleanup, as Luc and I used to call it. We have to clean up the mess. So, and we started to look for all the original material, and based on that material, we started to compare all the populations, and then we end up with a lot of publications on some of these species. And the last one, the last big one, I see there is one missing, but the last big one was actually made in 2019 when we did the cavum bearing, so the species with the cave. That was a general introduction. I don't want to say more about where is the genus placed in the systematics. That is actually not necessary. I think the first group that we will start with is a group, and as you can see on the top pictures, they all have a spot, but in this spot, you cannot see an extra line. So it's just somebody with his thumb who made a marking on the valve. And these are all the species that have a sinus. And I can tell you that the first one, the second one, the third one, and the fifth one are species you can find in Europe. Why do I put the fourth one here, this Heinaldi? The reason is because it was often reported from Europe, and I think it's important to show it here that this species exists. There are some more species in Europe, and I will show you some, but they are either extremely rare, or for instance, only in the high north or in Scandinavia or in the Arctic, or at the moment, not really well described. So if you look at these 5 species, take out the Heinaldi, these 4 species, these are the ones you can find in Europe. And you also probably will find, yeah, so maybe not amphibian, but the other 3 you will also find in Italy. Let's start with the first of the first, and that is Planothidium lanceolatum. And Planothidium lanceolatum is the most easy one, but on the other hand, also the most complicated one, because it can change his shape from going from large to small. And I usually always make my workshop first. You have a general page with a general description where you have the length, the width, the number of striae. Usually I put it there. And then I always show where the original material comes from. And the original material actually comes from Kutzing, 1846. So we are talking 180 years ago almost. That is where he described the species. And that is all it says. Agnanthidium lanceolatum, he described it as an Agnanthidium. And he just says a description, but no drawing. And then it's for us to go and have a look, and it says Falaise, which is in Normandy. It's in western France, and it was material given to him by Alphonse de Brébisson, who was a scientist there, and he gave a lot of material to Kutzing. So we went to look for that material, and I'm so happy that I have a huge collection in Messe with a lot of these type materials, and we found a type material. And this allows us to make a good observation of the types. And what was not done in the green books, for obvious reasons, because there every picture had to be taken with a normal camera on and developed and put on paper and so on. Nowadays, you can make 100 pictures per hour with your digital camera, and it doesn't cost anything except for the camera. But now we can make a lot of pictures, and you can see the whole evolution from the longer valves which are in the middle slightly inflated, and piece by piece by piece, this inflation becomes smaller. And if you look at the smallest valves, you end up with a nice elliptical species with actually not really an inflation in the middle. It's very, very, very slightly present, but not. But if you put in your book this one, number 27, and number 2, and you say this is the same species, nobody is going to believe you, because it's the shape is so different. But it helps by looking at populations like this to be able to put your species there. What is also very typical is that on one side you have this spot everywhere, and on the other side you see that the striae are only very weakly shortened. You see here there is, you can see there is a little bit curving here. Also here there is the middle one a little bit shorter, but it's not too much. That's very typical for Planothidium. And this is the raveless valve. And now if we go to the ray valve, you can also see here how it looks in girdle view. And in girdle view, like every Agnanthidium, Planothidium, it should be bent a little bit, but not too much. You see it's a little bit bent, like this. But the ray valve also has, of course, this inflation in the middle. And when going smaller, the inflation disappears. What is also important to realize is if you look at the tops, the apices, they are broadly rounded, which means they are not protracted. So it's not that it becomes smaller and it continues, as we will see later, for instance, in the group of Planothidium frequentissimum. So how to take this one, separate this one from frequentissimum? Well, just simply look at the tops. This one is weakly protracted and broadly rounded, whereas the other one, you will see, it will get thinner. Another very important feature, and I only realized this when I was writing that paper in 2015, if you look at the central area, you see that it's asymmetrical. On one side, you can have striae that are a little bit shorter. On the other side, there is nothing or very weakly some striae. But the whole series, you can see that it's always one part. The empty part is a little bit wider, and then you have the part with the striae, with very short striae. And this is very, very typical for Planothidium lanceolatum, which you will not find in, for instance, like frequentissimum, which is another species that is very common. You will not find it there. So the size, together with the apices and the asymmetrical central area, can help you in really well separating that species. I put some pictures of the electron microscope only to show you, for instance, 53 and 55. You see here striae short on one side. On the other side, well, yeah, you have 3 small areolae, but in the light microscope, you will not see it. Same here. You have here, and here you have striae. On the other side, you don't. And very interestingly, if you look at this picture 52, you have one where you have an asymmetrical central area with broadly rounded, and you have another one with a very small rounded and a little bit protracted. This valve is frequentissimum. And look at the central area, you really see the difference between the two sides. They are almost identical here, and they are not identical in the lanceolatum. So that's a difference between, on one side, frequentissimum, below here, the smaller one, and the larger one, which is lanceolatum. On the outside, I just want to show you the raveless valve, that there is nothing to see on the spot in the middle, but on the inside, you can clearly see this round thumbprint that somebody put on this frustal. What I usually try to do is I usually try to add also information from books that most of you will use, or from literature that has been verified. And if necessary, I even correct this book. Horst knows this. Horst always comes to my workshops too, and then he goes home with 3 or 4 pages of notes that he has to change. He likes it. He once said to me that, well, in front of everybody, when I was criticizing him on his books, and that he made mistakes, and he stand up and he looked at everybody and he says, "Shit happens." So everybody was laughing, and that was on the Planothidium workshop. So Horst knows about this, that I sometimes correct his mistakes. But this one is perfect. You see, it's almost not protracted. It has this nice spot. You can see the separation here between the asymmetrical central area, larger on this side, smaller on that side. So this is nicely Planothidium lanceolatum. Same with some books and some atlases. Maybe you use them that Luc has been making, and you see it's all representing always the same, the asymmetrical rave valve, always on one side, almost no striae, on the other side, shorter striae, but still visible. Here again, you can see it's always the same. I just want to put more information there so that you see that all these populations always show the same structure, the same type of observations. Now, I always try in my workshops to show you what the different species are that you can confuse with. This is Planothidium lanceolatum. I told you, on one side only a few or no striae. On the other side you have the sinus, just a spot. And if you look on the other side, you have Planothidium frequentissimum, another very common species. And if you take the raveless valve, you see that there is a line. I'm now doing the line with the red pointer. You see this line, and in fact, this is just the cavum that on the inside closes the spot, and you see actually this line is the top. Try in your microscope when you are looking at Planothidiums, try to change your focus a little bit so that you can go up and down on this point, and you can see either, like here in lanceolatum, there is nothing, just an empty depression, or you have this cavum. And what you can already see also, if you look at lanceolatum, the spot has no limit. There is no thick line that shows where the spot is. If you compare this with lanceolatum, you see that there is a big ridge. See, this is fattened here. This is strongly silicified. And that is because you have this hood, this cavum that goes over it, and that is made of a lot of silica. Also, go now to the rave valve. You see with frequentissimum has striae well developed on both sides. If you look at lanceolatum, there are striae only on one side of the rave valve. If you look at the shape, this one is more lanceolate, rhombic lanceolate even, whereas in the lanceolatum, it's more linear or linear lanceolate. I usually always put also some ecological data that I find in old books, that I found in the works of Van Dam. What I write here is what they have in their book. It's sometimes the same for a lot of species, because in the old works, in Kramer, Lange-Berthelot, and in Van Dam, some species were this broad, and now we put them back in small entities. So I will try to, when I say be careful, it's for the whole group, then I will write here for the whole group. Otherwise, it's for one species. This is better, Lange-Berthelot et al. 2017, because they already use most of the new species. And then what I try to do is, there are some other species described in Europe with a different name. And you also find them in, for instance, the Kramer and Lange-Berthelot books, the Süßwasserflora. And this one is, for instance, Agnanthes boei, was described by Oestrup. So I asked for the original material. I got the original material, and to my big surprise, I don't see a difference. If you take the whole population and you take the whole population of the normal lanceolatum, there was actually no difference. And we published this in Notule Algarum in 2019. And if you see all the green and the pink one, they all overlap. So we have no possibility to separate these two. And then we decided we skip the name boei and we put it as a synonym of lanceolatum. Maybe if one day molecular science shows that it should be separated, well, at least they know how the type looks like and that in morphology you cannot separate them. There is one other species that has also been put together with lanceolatum, and that is Agnanthes lanceolata var elliptica, described by Klever in 1891. I have no idea how it looks like. I have no idea if it belongs in this group. Maybe not, because you can see that the cavum or the spot is very well developed, but I can't find the type material. The type material is in Stockholm. Stockholm is closed till at least 2026, already for 3 years, and it's going to be closed for another 3 years. And they have no idea if they still have material or slides from Klever. I know that as soon as Stockholm will open, I take a plane and I go there and start looking in that museum to find that material. They said that I'm welcome to come. I will do this with Paul Hamilton from Canada, because we are both waiting for Klever material to be examined. So it's maybe something different. You maybe have it in Europe, but I don't know. That was the first species. That was Planothidium lanceolatum, and it's by far the most common one. I always tell my students, this is one you will find mostly in running waters with higher trophy. So polluted, higher trophicated waters, running waters, you will find them. If you find Planothidium lanceolatum in very oligotrophic small brooks, we need to look at the population, because it may be something else. Now, second one, we take the lanceolatum, but we inflate it, we make it fatter, and we give it on both sides a small head. It was described by Grunow in 1881 from a mountain in Austria, so not far from Italy. And this is all we have. We have these two drawings. We can try to find more. I often go to Vienna to look for material, but I didn't find that material. So the only thing I have is a population that I found in Sweden. But this population shows all what we need to know. It shows that the valves, both the rafeless valve and the rave valve, sorry, the first one is a little bit teratological. The tip is a little bit teratological, but that can happen. What you can see is they are fat. They are rounded, oval rounded in the middle. And on both sides, you have a nicely developed, protracted apex. So they have a rostrate tip. If you look, you have a spot, but there is a sinus, but no cavum. This is important to notice, because there are species that look similar to this one that have a cavum, that have the line in the middle. So be careful. Always, the first thing what you do when you look at a Planothidium, you look at the line in the middle. If you go to the rave valve, you see that the central area is quite small, and there is striae on both sides, and sometimes, like for instance this small one here, sometimes they can be a little bit asymmetrical, but usually it is rather symmetrical. So you have on both sides. Now, Horst has put this in his publication, Planothidium dubium, in his book, and that is perfectly what it should be. This is Planothidium dubium. It was also found in the region of Rhone-Alpes. It was also found in Burgundy, and you can see it's always the same. You have an elliptical shape, you have nice tips, and you have a sinus and an almost symmetrical central area in the rave valve. This is all Planothidium dubium. I got this nice population from Macedonia, from Zlatko, and you can see everywhere it's always the same, nicely elliptical valve with some rostrate tips, sinus, and a symmetrical of almost symmetrical rave valve. It is again same rivers, eutrophic, alkaliphilous. So it's again a species. If you find it, it does not indicate too much nice conditions. There is one that is quite similar to Planothidium dubium, and that is called Planothidium reichartii. It was described in, I can show, it was described in this yellow book, in the spring, in the, it's in the orange book. I think this was described here in the Sardinia book. And yes, there it is. Sorry, no, it is in the, sorry, it is in 13. It was in the spring book. It was in this one, the yellow one. And they separated it from Planothidium dubium because the valves are smaller. They are not so elliptical. They are more nicely lanceolate, and their tips are larger. And it seems like somebody cut them off. They are a little bit more truncated. And that together makes a very nice Planothidium reichartii. So if we look the features of this species is it has a nice small sinus. The sinus in dubium is larger, is broader. It has narrower valves, rostrate apex. If you look on the rave valve, you see that it is again compact as a species, and it has an asymmetrical, usually asymmetrical, sometimes weakly asymmetrical central area. These are some electron scanning, electron microscope pictures from the book, from the original description, and you can see that it's clearly a sinus. There is no cavum, there is no covering, so you will never see the line. There are some populations in Europe, so it is present in more places in Europe than you think. This is what Luc and Valérie Peters found in Burgundy region in eastern France. You can see a species which is compact, rather narrow from valves with two rostrate apices. Why do I show all these populations is always check there is no cavum. There is no line that crosses the spot. This is very important because I can imagine that this species has been identified as Planothidium rostratum or Rostratum holarcticum by many of you. I did that also at the same when I was starting with diatoms. This is not rostratum because rostratum is a species where you will have this sinus, this cavum. So you will have the line in rostratum, whereas in reichartii there is no line. I recently found a very nice population in a sample sent by Ingrid Juttner. And here you can really see that there is no line and the spot is not well defined. So there is no circle, siliceous circle going around this spot. If we see later rostratum, you will see that there is this spot. You also see in all these rave valves that it's always asymmetrical in the middle. On one side, you have shortened striae. On the other side, you have actually nothing. There is just an empty spot. This, and I find this very strange, Horst describes this oligo to eutrophic water bodies. I'm not sure if this is entirely correct, because I cannot imagine a species that uses both oligotrophy and eutrophy in the same species, but until proven, we have to accept this. So in the yellow book, they make a nice comparison between Reichardtii and dubium, and you can see the difference between the two shapes. Dubium is elliptical and rounded, whereas Reichardtii is much narrower and actually a little bit more compact as a species. Look also at the tips; they are all different. If you look at the diatoms from United States website, I doubt that these forms, these three, belong to dubium. They say it's all dubium, but I don't think that is true. I think that either these three represent a species from United States or Reichardtii. So be careful with published images on the internet. Always use a critical view when you use these. If we go a little bit narrower and we add a little bit more striae, we have a species that was always called Agnanthes lanceolata, subspecies lanceolata, variety Hainaldii. And this is Planothidium Hainaldii. And if you look in the, where's my green book? If you look in the green book, this Hainaldii was also often reported for Europe, which is actually quite strange, because it was described from Antizana, which I think is in Venezuela. And this is all we have. This is the Schaarsmit 1881. This is the whole description that we have for that species. Unfortunately, we don't have, sorry, it was not, it's Ecuador, it's not Venezuela, but it's the same region. So Carlos, me, and some other colleagues, and Luc, we studied the type material. So we got the slide. This is the original Schaarsmit slide. We got some drawings from other people. And what you can see already is that there seems to be some strange changes going on in the interpretation of people. In BC and DE, these first two, it's an empty spot, which will correspond to a sinus. In the other ideas that Patrick and Reimer had and that Hustedt had, you see that they make a thick line. The only thing that this thick line is not showing is this line in the middle, but most likely these two have a cavum. So you have to separate the four pictures on one side from the other ones. But we managed to find enough specimens in the slide. This is the original slide of Antizana. And what you see is it's actually a centric part, a round part in the middle, and two heads put on each side. So you have a round central part with a capitate end and another capitate end. Here on number 1, you can see very clearly. It was not possible to have everything in focus, but don't forget, you can see it here clearly, Agnanthes species, and Planothidium belongs to the Agnanthes group, it's always bent. So either you have the middle part in focus, or you have the tops in focus, or you have half of the valve in focus. So it's always difficult to see that. So this is the real Hainaldii as you can find it in South America, probably not in Europe. The same you can say for the rave valve. Look at this, 13 to 15 striae, and you see that the striae are much closer together and are much finer. In the central area, it's usually not asymmetrical, so it's usually symmetrical. Be careful with this number, what is it, 16 here, this one, or this one here, because the two valves are so closely together, we could not make a good picture. So what you see here, this spot, is actually the other valve, the rafeless valve, that is glued to it. So don't take this picture into account. Be careful with that one. So that is the real Planothidium Hainaldi. Now then, what to do with all these species here? This is Hainaldi, like Horst put it in the green book. This is Hainaldi, like Patrick and Reimer said. They showed this cavum type structure, but we don't believe that there is a cavum. We believe that they actually, in their fantasy, they put a cavum there. Because we looked at the material, and as you can see, you cannot find a cavum. It's all sinus, but the valves are much narrower, and the heads are almost as wide as the central area. So these, and this is the real Hainaldi, so these, we believe we should not keep in Hainaldi, and we should put this together with another species. So what can I say about the real Hainaldi? It's a species that is probably only present in South America. It is not present in Europe. And if you compare this with similar valves that you can find in Europe, here you do have, look, this one on top and this one below, you have this nice line, and you even have, you can see it here on this picture on the bottom, and you can even guess it on the picture on the top, you have a cavum. So it is closed halfway. You see that it's closed, which you do not have in this Planothidium Hainaldi. The top one is called Biporomum. I'll talk after the first break about this one. The lower one is what we called Incuriatum. I also will talk about this one on the break after the first break. So Hainaldi has a sinus, Biporomum, Incuriatum has a cavum. So now let's have a look at the last one of this group, and that is this Planothidium amphibium. It was actually the false Hainaldi from Europe. It was described, I think it was described from United States, but it's also present in Europe. This is the original description that Luc and Carlos and Laurent Pfister have been making. And as you can see, or maybe I'll do it like this, that's easier. As you can see, the shape is different from Hainaldi. You have a more compact form. It's not that big, round center and then two large heads on both sides. No, it's a compact form, but you still have, on all these forms, you have the presence of a sinus. There is no cavum, there is no line, there's no delimitation of the spot, there is no cavum. I really stress on this difference between cavum and sinus, because when I started diatoms, I made a huge mistake, and I never looked at this sinus cavum problem, and I confused a lot of species just because of this. The same if you look on the Rafe valve, you can see that it's almost a symmetrical area, sometimes asymmetrical. I write here central area asymmetrical, lacking a complete fascia. In some cases it's asymmetrical, in some it's symmetrical. It's a little bit, it's a bit in between the two. Usually it's asymmetrical. If you see here, there is a gap, there is a gap, there's a gap. We should have turned this around. We should have turned this around, but it's okay. Horst has put this in his green book, but it has no separate entry. It is somewhere in the remarks of another species. I forgot in which species it is. I can have a look. Wait, I'll have a look in my book. It's easy to have the book next to you. Oh, it's given as a remark to Planothidium lanceolatum. So you'll find it on page 509. as a remark, but it is found also in Europe. This one comes from the Diatoms of the United States website, and it's sold there as Planothidium hainaldi, which is not the case. We know this now. This is not hainaldi. This is Planothidium amphibium. All the mistakes that I see on the Diatoms of the United States, I also transferred to Sarah Spalding, and she then can change this on her website. So most likely, records in Europe of hainaldi represent Planothidium amphibium. So I'm not sure, I don't know if you have it in Italy, but if you have it, check carefully because it might be Planothidium amphibium. So here you see again the difference between amphibium on one side and hainaldi on the other side. And you really see that the structure is really, really different. The striate density is almost the same, but look at the shape, look at the size. This is much wider, 7 to 9, and the other one is 5 to 6. Both have a sinus, which is very, 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 very important, because after the break, we will see some species that look exactly like this amphibium, but with a cavum. So really, I cannot stress enough on the fact that you have to check between cavum and sinus. Look at these, that looks similar in shape, but these one have a cavum, these two, that one has a sinus. Now I put one species here that I found in Sweden, and I have no idea what this is. I don't know if some of you have found this in Italy one day, but if you have it in Italy, please let me know, because for me, this most likely represents a new species. But there are some North American species that show some resemblance. The only problem is the type material of these species is no longer there, so I cannot compare it. So most likely, I'm going to describe this as a new species one day. If I get rid of all the rest of the manuscripts in my office, then if I find 5 minutes, I will describe it as a new species. And I think we are now almost an hour gone. We should have a short break of 10-15 minutes and also allow you to ask questions if you want. And we can go back to the slide and discuss if you have questions. You can ask the questions in Italian. I cannot promise I will answer in Italian, but I'll try to understand what your question is. And I think Raffaella or Elisa can help me with translations.
Yes, thank you, Bart. Se c'è qualche domanda. In chat non vedo niente. Is all okay, is all clear, Bart.
All clear?
Chiarissimo, chiarissimo.
Excuse me.
Yes.
Excuse me. Could I just a little question? If I have no idea what species this is, and it's possible just find in Italy, probably. I suppose how I could describe it.
You mean this one from Sweden? You have it in Italy?
No, if
you find it in Italy, you just write
some SP. Just how can I express the thing, the question, the problem. If I have no idea what is the species, if I could just to ask to you.
Yes, if you have this species and you have no idea what it is, just contact me, and I will try to find a solution. But I will one day I will describe this species. The only problem is that I only have a small population, and I prefer to have larger populations so I know the exact I know the exact cell cycle, how it looks like from very small to very large. But most likely I will describe this as acuto lanceolatum, for instance, because it's very acute, very pointy. So I probably will describe it as a new species, but I need to check what the Americans do. And if you find this species at the moment, you just call this SP, and you can even refer to this workshop, workshop species from Sweden, because it has no name. And if it has no name, I would not say this is lanceolatum, because your ecology will be wrong. Because as far as I remember, this was found in a not so dirty water, and lanceolatum is really polluted water, and this one is not so polluted. So you will decrease, actually underestimate the water quality of your river. So better is to put SP. If you find only one valve, who cares about one valve? If you find more than 5%, it's time to do something about this species. Is that answering your question?
Okay, thank you.
Another...
Bart.
Yes. Hi, Valentina.
Hi, Bart. Thank you very much. Can you please repeat the main characteristics of amphibium, please?
Amphibium, again, wait, I'll try to go back to amphibium. So the main feature of amphibium, it is a rather small species. It's rather compact as a species. It has always an inflated part. It has a belly. It has it took a little bit too much food. It has a belly, so it's rounded in the middle. And both the heads are also a little bit truncated, but they are still, you can still see that they are separated from the rest. If you look at, for instance, the real Planothidium lanceolatum, you will never see this change of direction here around the heads. It goes smoothly towards the top. You will never have this. You will never have this rounded belly in lanceolatum. It is asymmetrically rounded in the larger specimens, but look at the smaller ones. You will never have this shape in lanceolatum. What I always, because when people ask me, can you give me an idea about species X, species Z, and so on, they send me one picture. You cannot do anything with one picture. You need to see a series, and that's usually what I ask the people is send me the slides, send me material, let me have a look in the population myself, then I can have myself an impression of what the whole population is. I do the same with Fragilarias. Fragilarias, if you send me one valve, it's nice, it's a Fragilaria, and that's it. I need series, but this one is in the whole valve series, and even if you take the other side, it's always the same combination, the inflated central part on both sides, and the very thick but protracted apices. That's typical for amphibium. Be careful, this is a shape that we will see more today. There are some other species, but they have a cavum. This one has a sinus. Now, a very important question, what if you only find this in your valve, in your sample? If you find only one, try to put a name, but if you have to write SP, it's okay. Because if you find this Rafe valves, one day in your sample, try to find in other lines, you will find one either with a sinus or with a cavum, and then you can put the other one together. It's like with coconaes. Is it Euglypta or is it lineata or is it placentula? If you have the Rafe valves, nobody can say anything, not even me. I cannot make a distinction. I always go and see what are the Rafeless valves in there, and then put the two together. And if you only have one, it influence your water quality. But if you have 10%, if you have 10% of this here, what you see here, you always will have valves without a rave. It's not possible, because if you only have things like that, you're probably not in Planothidium, because then there is no raveless valve. So you always have a raveless valve. So for Planothidiums, it's very important always to have a look, what are the rave valves and what are the raveless valves, and then combine the two. We will see this later also for the other groups with the cavum, and even without sinus and cavum, it's always important to put the two together. Okay?
Another question in the
Thank
chat,
you.
Bart.
Yes.
Fogliatti ask if we can find Planothidium in colony or not. Is it colonial species or not?
No, but I will go back to one of the first pictures. Okay, this looks like it is a colony. If you want to call it a colony, you can call it a colony. But they have no spines, so they are attached together with mucus. And I was really surprised. This is the only one, lanceolatum, the type material of lanceolatum. This is the only one where I could find them together. But you have to know that this population was almost 90%. It was like a monoculture of one species of Planothidium lanceolatum. And we know from cultures that species can start to glue together with mucus. In nature, in normal circumstances, they will not keep together because the forces of the river will keep the mucus apart. As long as they don't have spines, like in Starosira, Venter, or Construens again, where you can have these long colonies, they will always break up. So I can really understand that people think that this species can form colonies. I don't think so. I think it's an artificial colony.
Bart, c'è una domanda in chat anche in inglese.
Is amphibium also convex, just like, yes, but less. So it's also, I mean, I think, Simona, do you mean, is it convex on valve face view or in girdle view? In girdle view. It is, but it's less. All Planothidiums are convex in girdle view. I'm going back to the picture. So here, this is really, this was one of the most convex ones that we have seen. If you look, you can never get this one in focus. Not here. You can see this one is out of focus, whereas this is in focus. Or you can have the tips in focus, but then the central part is not in focus. But if we go now to amphibium, mostly the whole part is in focus, which means that it is a little bit bent, but not too much. If it would be really bent like this, you cannot get everything in focus. So I would say not really too much bent. I don't think yeah, you see here, here is one. It is bent, but not too much. It's very difficult also for me to identify Planothidiums in girdle view. You can. If you would start with your focus on this central part, and you go from the top to the bottom, so you go all the focus levels that you have the whole scene, the whole thing, you will notice that in the middle, nothing changes. That means you have a sinus. But on the species that we will do after the break, you will notice that in the middle, suddenly a thick siliceous part will appear. That is your cavum. because the cavum is a structure. The sinus is not a structure. The sinus is actually a not present structure. It's just a depression, whereas the cavum is a siliceous structure. So you can already separate between sinus and cavum. Secondly, you have to start looking at the ends. In this case, you have the central part in focus and the ends not in focus, which means that one of them is inflated and the other one is less inflated, because otherwise, if they would both have been inflated, if this part here on top would have been as broad as this one, the whole part would be in focus. Okay? But I admit Planothidiums in girdle view are not easy. You can separate between a cavum and a sinus. That is not that difficult. But between the groups, it's not that easy. And usually what I do, it's the same like with coconates. Go and have a look at what is more in your slide. And if you have a lot of lanceolatum in your slide and you find also some valves in girdle view, most likely they belong together.
Another question, Bart.
Yeah,
is,
if you can find lanceolatum in...
Yes, in substrate, siliceous substrate or not.
I think it's less common in siliceous, on the siliceous substrates than in more alkaline calcareous substrates. But I didn't study enough ecology to answer that, but I think when I look at what Horst wrote about it, I think mostly you will not find it in siliceous substrates. And also not in acid substrates, definitely not. Planothidium is usually Planothidium species are not in acid circumstances.
Okay, for now there is another question, or we stop for 5 minutes.
Yeah, then we all can
Take
get
a
tea or
little
coffee.
break. Yes. And so
so it's 10:40. Let's start again in about 10:45.
Yes.
5 minutes. Is
Yes.
that enough for everybody?
Yes, yes.
Good. Then we can
Okay.
go and have another coffee.
Okay.
Good.
Super.
See you in 5
Thank
minutes.
you for now.
See you later.
So Bart, if you are okay,
Yeah,
when you want.
good. Right. Second group, that artificial group that I made, are all species with a cavum, and you can see that there's everywhere here in this case in Curiatum picture and Gallicum, you can see it very clearly. There's this line in the middle, and you have a very nice delimitation of, you look at this Planothidium potapove, you have this line that surrounds completely the cavum spot. It's always a very, and they call it a horseshoe spot, and that's how they call it in the book, horseshoe spot. All these species are more or less in the same shape. They have a lanceolate elliptical central part, and on both sides they have rostrated, even sometimes more capitate apices. Look at this one, this potapove. It's really elliptical with rostrate capitate apices. This is an artificial group. It's not that they have anything to do with each other. It's just to help you. If you find something with a cavum, a little bit elliptical with a rostrate head, you can go to this page and try to find it on this page. And then you can develop further how to work with it. We start with the first one, and that is Biporomum. You know this as lanceolata subspecies Biporoma. It was like this, described in Horst Süßwasserflora. Well, not described, it was put in the Süßwasserflora. I don't think that this species is common in Europe or even present in Europe. It is a North American species, and it was described from Colorado and from Canada. And if you look at the original description, Horn and Hellerman, who described the species, if you look at the drawing of the Raveless valve, you see that they make the cavum, and you see that the cavum, the line, crosses the first striae on both sides of the cavum. So you see that. And if you look at the picture that I took from the Diatoms of the United States website, from the type material, because they could not send me the type, it was not allowed. Look here, you can see that it crosses the first stria. Here is a stria, there is the stria, and you see that the cavum crosses it. So this has a huge cavum. We got some pictures, and you see each time you have this cavum. Remember, this Planothidium amphibium, it looks a little bit in this shape, but amphibium has no cavum. And here you can really see this huge, large cavum crossing always the first striae. The Rave valve, yeah, that becomes a little bit more a problem because they are a lot like this. It's a weakly asymmetrical central area with striae on both sides. But if you see this, and I show you 5 pictures of amphibium and I mix them, it will not be that easy to separate them. So always go back to the Raveless valve. This is why this cavum is so large, you can see it's usually like a big trumpet, and it crosses the first striae. You see that here's a striae, there's a striae. On the outside, you don't see anything because you never see a cavum on the outside, but on the inside, you really see why it is so big. If you look at the website of Diatoms United States, which I use a lot, you can see again, it crosses the first striae and even reaches almost the second striae. Probably only present in United States, alkaline medium conductivity levels. That's all we know at the moment for the ecology of that species. We need more information, I know, but it's the people from United States that have to find it and say where they found it. Together with Luc and Carlos, we started to look at all the pictures that were published as Biporomum in the world, and we realized that they all have the same shape. They're all longer, elongated, not so fat in the middle, and with very short but still rostrate ends, apices. And we decided to describe this as a new species, and it's called Incuriatum. And I can tell you that all the populations in Europe of Biporomum that I've seen actually are all Incuriatum. So I think that also in Italy, if you have Biporoma in Italy or Biporomum in Italy, have a second look. It's possible that it will be this Incuriatum. Incuriatum is always, I will go immediately here because this is the original description. So you have it, you have everything together in one presentation, which makes it easier. You don't have to look in 5 books and 20 papers and so on. We've made that already for you. Look at this. They have a very fine striation pattern. They have a small cavum, but it crosses to the first striae. But more important, and that is the difference with Biporomum, it is long, it's elongated. So if you would calculate the length divided by the width, this would be much more in this one than in Biporomum. And that also makes that if you look at the rave valve, it's much easier to identify because it also has this rather fine striation and this very long shape. These are pictures from the type material for the electron microscope. They come from the original publication. You see, it also crosses the first striae. So that is not a feature you can use. But what you can use is the difference in shape. So this was put in the book by Horst. Very fine striation. Has this, he calls it a tunnel-like hoof mark. You have these 2 lines. You have the line in the middle. You can see this. Yeah? I hope you noticed that. There is this line. Always check for the cavum. Okay. This one has rostrate apices that are well separated. And it's always this lanceolate shape. If we will look afterwards for the frequentissimum, you will see that it has a different shape. Look, these are all Incuriatums, but they have been mentioned as Biporomum. Of course, because in that site, 2013, Incuriatum was not even described. We described it in 2015. Because at that time, the only thing we could do is use the book that Horst made, the Kramer and Lange Bertalo, in 2000, and there it was as Biporoma. In 2018, it was already mentioned as Incuriatum. But you see, it's always the same, elongated valves, very fine, dense striation. Look, this is Incuriatum, this is Biporomum. I hope this is clear that they are different species. And this also shows why it is so important to check the original material. Because if you don't check the original material and you say, yeah, we are working on this one at 2029 on this one, and this is Biporomum. No, this is another species because the type looks totally different. And that's why we always try to find the type material before making any conclusions. So this is the difference between the two. The ecology is, Incuriatum is as lanceolata subspecies Biporoma, because I think that in that book it was called Biporoma. You can say it was oligotrophic, electrolyte poor, so lower conductivities, and almost circumneutral. So it's an oligotrophic species. It's one of the better ones. If you find this, your river or your lake is in a better condition. Now, Kramer and Lange-Berthelot also put in their book other figures that they identified as Biporomum. But we realized that it was actually smaller and has a little bit different shape. And then we described this as Gallicum, the species from France. Gallicum means from France. It's a compact species. Be careful. It looks similar to Amphibium. But look, everywhere you can see the line in the middle, which means it has a cavum. Amphibium has no cavum. It's a smaller species compared to Incuriatum. Incuriatum is longer, more elongate. It has typically subcapitate apices. You can see that. They are protracted and a little bit widened. This is what is, for instance, different from Frequentissimum that we will see later. Again, if you have this only, it will be difficult to separate it from Amphibium, because they all look a little bit the same. It's like with Coconeus, the Rafe valve is difficult to separate. But, for instance, if you look at the cavum type, the cavum does not cross the first striae. Here also, you can't see it. See, you don't see that the cavum crosses the first striae, which is the case in Biporomum and which is the case in Incuriatum. This is a population from Sweden. You can always see the line, but you can see that the line here that touches the first striae, but not covers it. Same here, same here. You see, it's never covering the striae. So this is probably also Gallicum. Here is a difference between Incuriatum and Gallicum. Look at the size difference. This is much smaller, although in Biporomum you can have smaller ones. And the striae density is actually higher. It goes up to 18, whereas Biporomum stops at 15. Remember, Biporomum is probably not in Europe. So you better use the name Gallicum. I just was working on a sample from the Flemish Environmental Agency, and I came across a very nice population of this Planothidium gallicum 2 weeks ago. So it is possible in Europe to find nice populations of Gallicum. The same with Incuriatum, that is present in Europe, but look at the size differences. Incuriatum is larger, striae are the same, but look at the shape. The shape is totally different. This is a long, elongated. Gallicum is actually more compact species. Ecology of Gallicum, I think mesoeutrophic alkaline rivers, so higher pH mesoeutrophic, but it's at the moment not sure because we have it as Biporomum, but Biporomum is also Incuriatum. So within the name Biporomum sensu Kramer Lange-Berthelot in Europe are now a lot of species. We can go even smaller, and also Kramer Lange-Berthelot may have put some species in there. We have no idea what they all put under their species name, and it's a smaller species. It was described by Gogorev and Lange in Russia, but we found it already in Europe. My Russian is not that good, but it was described in Russian. It's also a little bit in English. They say it's the same as Biporomum and Incuriatum, but it's much smaller. So now let's have a look. This is a population from France. You can see it's an even more compact species than Gallicum. It never will be that large, that long as Gallicum was. It is nicely rounded in all its parts. It has a rounded central area and a short rounded apices. If we will later see the real frequentissimum, frequentissimum is more rhombic lanceolate and has rostrate short apices. They are not that well pronounced, as you can see here in this one. You can have the cavum. The cavum is very much placed at the side of the margin. I thought I had more pictures of the ray valve, but the ray valve is very short and compact. I would measure this species and determine its number of striae. I go just back to the first slide. 10 to 15, 4.5 to 5 is very small. Sorry, it's very small for a Planothidium. It's one of the smallest Planothidiums with cavum that you can find. There are lots of Planothidiums without anything, without cavum or cilia that are smaller, but this is a very, very small species. You can see also that the cavum does not cross the first striae. You see here the first striae is lying here. And this was already described by Francois Straub, our Swiss colleague, in 1985, and he called it Agnanthes rostrata capitate type. We know it has nothing to do with rostrata. That will be clear in a minute. It has nothing to do with rostrata, but it is that species, and we used his population. These pictures were taken from this population. If you compare it with Gallicum, which I do here, you can see that Gallicum is larger. You will never have a Gallicum that goes up to 10. So they will never that small. And it's wider. Gallicum goes to 6.5. Alexeva goes to 5.0. It's not even the lower border, the lower limit of Gallicum. Striae numbers are the same, but that's typical for these smaller Planothidium species. You also see that the apices in Alexeva are more truncated, are more cut off. So somebody took a knife and cut off both sides. That is typical for Alexeva. The same with Biporomum. Biporomum is a larger species and has a lower striae density. And Incuriatum, yeah, I don't think I have to make confusion with Incuriatum. Incuriatum is a totally different species. It was described from brackish water in a subpolar lake. I'm not sure if that is the conditions you will find it in Europe. But we know that it is in Europe. Unfortunately, Francois Straub gave no indications on the ecology of his population. So that's the only thing we have. And I think for a lot of these species, this is up to you, people that are working with these species, to actually establish the ecology of these species. The only thing we can give you is how it looks like, and it's up to you to do something with it. What I would suggest is, if you find this species, look at the other species that are in that same sample and use the ecology of those species to establish the ecology of the one that we don't know. And if you do this in a lot of samples, at a certain moment, you will find a common general ecology for that species. I add one rare one, and that is Planothidium potapovi. I've seen it once in Belgium in a sample, in a very small. This is a very easy one to identify because it's almost rounded with two long heads and a very, very, very large, you can see that, a very large central area. You have this in Europe. It's described from Europe. It's named after Marina Potapova from United States, but it is in Europe. And I've seen it already in Europe. Another one that I just mentioned, but you will not find in Italy. It's an African species. It was described from, I think, Sierra Leone. It's Planothidium piaficum. I just put it here to give the complete information, okay? It's not in Europe. It has a very strange, ultrastructure in the electron microscope. You will not have it in Europe. So now, a big problem. The problem called Agnanthes rostrata. Probably if I ask now who has found Planothidium rostratum in Italy, a lot of you will say, yes, we have. And I'm going to say, no, you don't. Because it's a species described from Indonesia. From Klong Sarlakpet. It's an Indonesian species and described in, what was it? 1902 by Östrup from somewhere in Indonesia. The original material is not there, but, oh, sorry, the original material is there. It's this one, sorry. And as you can see, this is almost a circle species. It's completely round. And on both sides, they put a small dot. And these are these heads. But what is very typical, these heads are very elongated. They are long. You see, it's very long. It's like somebody took it and tried to make it longer. Even in the smaller valves, it's still visible as a typical rostrate apex. See, it's typical rostrate. It's typical rostrate and long. We also have material from the same locality, almost the same locality, from Lake Toba. And there it's always with long apices. There are a few exceptions that makes it more difficult, but it's usually long. This is the Husted collection that gave us this material. You see very long apices. Now comes the problem that was created and that we all had to deal with. Horst put all these as rostratum. But it's clear that this is the type material. This is Östrup material. These are North American ones that we believe may be new. It's maybe this one is maybe even Alexeva. These last three. The other ones, they look similar, but we could find differences in the shape. And then you have this one, what Horst separated as the variety rostratiformis. The only problem is that we cannot combine this and this one. In the first new Süßwasserflora, the blue one, he put these two and these three together and says this is Planothidium rostratum. That is in the blue version. That was the first one. In the green one, he used the same pictures, but changed the place. He just made them a mirror. See, it's the same pictures. It's these, and these are the same pictures. But then he calls them all rostrato holarcticum. He just changed the names. But you have some which are rostrate with truncated, so cut off, and you have some which are long. These two are two species. You have on this side, so 45, 46, is the real rostratum, and these pictures come from the type material from Østrup, but Horst in his books, he likes to use pictures again. So he makes one-day pictures, and then you will find them in all his publications, always the same picture. And these three are now called rostrato holarcticum. And this one is the species you have in Italy, I have in Belgium. So that is called rostrato holarcticum. And you should exclude the type of rostrata out of it. But the ones that Hustedt made, some of them also fit in there. So this is what Hustedt described as the variety rostrata. But it's not correct. This is rostrato holarcticum from the Holarctis, which is the northern hemisphere. This is the type. And as you can see, the valves are not so rounded in the middle, and the heads are, somebody cut off the heads. They are broad and somebody cut off. So we call them, they are truncated. But it's actually very easy. I don't think that in Europe we have rostrata or rostratum. We all have rostrato holarcticum, which makes life a much easier for us. This is a population from Lac de Taillère. It's in Switzerland. It's material that I think we got from François Straub. So all these are rostrato holarcticum, but I would exclude maybe these two. I found another population. It was in Poland. Don't take T and U. This is something else. But this is again rostrato holarcticum, also European. Again, also European, but some of them are a little bit longer rostrate, but still, we believe if you look at the whole series, you might end up with rostrato holarcticum. Rostratum only in Asia. If you start to work on the Mekong River or on the Yangtze River, you can start looking at rostratum. Here you have again the difference. This one is more compact, and look at the heads. It's really different. So it's rostrato holarcticum. This one is more rounded. This one is more straight, these margins. It's subtle, these differences, but if I would put the molecular data, they will probably be separated. It's a mesoeutrophic species, medium to high conductivity, so it's again not the cleanest one. You can find it together with lanceolatum, you can find it together with frequentissimum. You have them in one and the same type of samples. These were the groups that all have a rostrate protracted apex. The new group that I would like to show you now all have a cavum. You can see that, and you can see the lines, you can see the well delimitation, but they all have no protraction in the apex. They are either cone-shaped, cuneate, or broadly rounded, or like in the typical frequentissimum, very weakly protracted. You see that? There's a very weakly change in the direction. That is typical for this whole group. And I put them all together so you can have an easy identification tool if you see them in your microscope. I would say these overviews, print these, and use these next to your microscope when you have a lot of Planothidiums. And start with these, and then look in the rest of the workshop booklet if you can find more. The first of all is frequentissimum. It was described by Grunow as agnantes lanceolata var dubia forma minuta. So it has nothing to do with the name frequentissimum. That was a name that Horst gave it because he says it has nothing to do with dubia. It has nothing to do with minuta. We're going to name it differently. This is the original drawing. And this is what we could make of it. These are original pictures. And this is what Horst made of it. The material is in my collection. It's in the Van Herk collection. So the easy thing is we can make as many pictures as we want because we have the type material. And what can you see? Everywhere there is a cavum. Also, the shape is lanceolate to lanceolate, a little bit rhombic lanceolate. And the apex in the longer ones, slightly protracted, but never this really big apex. And if you go to the rave valve, there is quite some symmetry in the central area. If you compare this with the real lanceolatum, it has never this shape. It is larger and it had an asymmetrical central area. In this case, you have a quite rather more or less symmetrical. You have at least striae on both sides. So this is recapitulating again. Rhombic lanceolate. See? Cavum, well defined with the line. Check for this cavum. And always 1 to 2 shortness striae on both sides. This is one here, and usually this is also one. Usually there are 2. Check for these striae, because this is what makes lanceolatum, what makes frequentissimum so typical. The combination of the rhombic lanceolate shape, the protracted apices, and then afterwards also this central area. This is how the material looks like in the electron microscope. Look at the cavum, very well developed, but never crosses the first striae. See, first striae is very thick and is bordering it. Horst made a very nice grouping of it in his book, and I don't think I would have to comment on this because he says there are 2 varieties, the var magnum and the var minus. Forget these varieties. We made different species out of them because they have nothing to do with frequentissimum. So you will see later in this workshop that we have separate species for it. Again, this is all this frequentissimum, and you can really see that you have a protracted cuneate apex. This is very important because there is a species that resembles it a lot, and even I don't have a good view how to separate it. That's Victorii. We'll come to that later. But it never has this cuneate protraction in his apex. For instance, I have problems. This is Diatoms United States. I'm okay with this picture. I have no idea about this one. Probably I'm okay. I'm okay with this picture. But this one, with the picture with number 1, I don't think that this is frequentissimum because it is too rounded. It's not protracted. This is, for me, this is frequentissimum is a species that you can find in the most polluted waters. And usually you find this in rivers that have been modified. I mean, they have been cleaning it. They have taken the water plants out. They have been not, instead of having it curving, they made it straight. Something happened with that river. It's actually an indicator for me for physical disturbance of the river. Now, Incuriatum, it has a different ecology, of course, but look at the shape. It is different, so be careful, don't mix them up. Rostratum or Rostrato holarcticum, it has a different shape. The only one that is not so different is what has been described as Victorii, a species which is described twice, 2 times. Once described from Australia as Victorii, but my colleagues from Berlin, Jonas Zimmermann and Regine Jahn, have described it as Planothidium caputium from Berlin. They did molecular study and it was exactly the same. But the problem is, this is the description from New Zealand. I would never, or from Australia, sorry, what is it? Australia. I would never describe a new species based on a teratological form. Look at this. Something happened with that species. It's just because it's a modified form, and afterwards they made a culture of it, and that's the top of it is the culture. So these are okay. It's from New Zealand, not from Australia. I thought from Australia. It's New Zealand. Wow, same area. This is a strangely shaped one. But this is, if you take a normal population, I think this is the Caputium paper. What you see, it's a lanceolate species. It's nice. It's convex margins, but it's not the rostrate margins. And look at the apex, the tops are not really well protracted. You don't have a pyramid on the top. I have to confess, this is very difficult to separate from frequentissimum, especially when you only have these smaller ones. Because even in this one, if you see the rave valve, I don't see the difference. I can go by shape. This one is a little bit narrower and has not this pyramid on his top. But if I go and see the smaller valves, I admit I cannot separate them. So I have no idea how to do this, but they should be separated. But ecologically, I think they are almost the same. So this is the description of Caputium. And as you can see, the European Caputiums, or the European Victorii, because that's the oldest name. Victorii was older than Caputium. That's why we have to use the name Victorii. If you see, they never have this protected apices and always this lanceolate, really clearly lanceolate, not rhombic lanceolate valve shape. So that is again their type population. This was now designated as an epitype. An epitype is an extra explanation for the holotype. And the holotype is this strangely shaped teratological form. So if you want to explain the species better, you have to designate an epitype. So it's epitype population. And as you can see, it's a nicely shaped frequentissimum one. So that's why they call it Caputium. They separated it. But honestly, if you mix them up, I don't think you make a problem. So if you do in your counts, you say frequentissimum and Victorii are the same, I don't think somebody will have a problem with it. It was described before as Agnanthes rostrata var magma. So this is this var magna. So it should not be magma, but magna. Magma is from the volcano. It should be magna. This is that frequentissimum var magnam. So that's why I say take this out, because it's now called Victorii. So here you have the two together. But I have to say, these two that I show you here are actually the most clear valves that I could find. I can give you 500 valves where you cannot see the difference. Look at the numbers. Length, same. Width, same. Striae, same. Because 14 to 18 and 14 to 17, that's not the difference. So I usually say the ones that are more lanceolate and that are not so cone-shaped, pyramid-shaped on the top, I put in Victorii. The others I put in frequentissimum. And as the name it says, frequentissimum is far more frequent than Victorii. So they even wrote it in their own paper that they have no idea what the ecology is, because they say it may be sensitive to contamination, may be a useful indicator species. I don't think so, because I also found teratological forms the same shape in frequentissimum. So I have no idea how to separate them. So I would call them together as frequentissimum, including Victoria. I don't think you make a big mistake. Now, one that you can separate is what we call cavi lanceolatum. Why we named it like this? Because at first sight, this looks like a, look at this, this looks like a lanceolatum. But, problem, it has a cavum. So it can by no means be a lanceolatum, because that should not have a cavum. So if we have a look at the Raveless valve, we see it's a very elongated species, but even in the shorter forms, it still has this rather elongate shape. It has the cavum. You can see that it has the cavum, and it has a very nicely dense striation pattern, very regular. And in the middle, the striae are almost not shortened. You see that? They are not shortened. Oh, sorry. And if you look at the Raveless valve, you have always almost symmetry in the middle on both sides, except in these very long ones. My mouse is not working properly at the moment, sorry. In this very long one, here you cannot see, okay, that's better. Here you can see that a little bit asymmetric form, but not here in these shorter ones. I'm going to take a paper. So, okay, that's better. It crosses the first striae. I'm not sure. Wait, I'm going back to the. Oh, I'm going back. If you can see, yes, you can see it. Look at this one here. It crosses the first. Here you can see it also. Here you can see it slightly. It crosses the first. This is a population I found in Flanders. Carlos and I decided that we should keep this together, but I'm not convinced. I find it too fat to be the same, but we decided to keep it together because it's the only one that is a little bit different, and I hate to make new species for every population that I find. So we call this cavi lanceolatum. What is the ecology? We have no idea, because this always was described as frequentissimum. But if you see, this is not frequentissimum. People called everything with a cavum frequentissimum. It's very easy. But the ecology has to be defined. Is it Victory? No, look at the difference. Victory is more lanceolate, more narrower heads, and it's smaller, 4 to 5, 5 to 7. Cavi lanceolatum is a really fat, big species. A new one that we described is this one, and it was also described here in I think, because I cannot, I think it's Hinsianum. This is described also as based on some pictures that some pictures that Horst has put in the Kramer-Lange-Berthelot under frequentissimum, but it's not, because it's always broadly elliptical to rhombic elliptical. So you see that there is always this difference between the more lanceolate rhombic shaped that you have in frequentissimum. They always have nicely rounded, maybe I can do it like this, nicely rounded, acutely rounded, non-protracted apices, and always a rather large central area, with, of course, a cavum, but from now on we are only talking about cavum species. This is more difficult, as I said. Ray valves are always difficult to separate in Planothidium, but the shape could help you, direct you towards one or either direction. It was found in an Husted sample. That's why we also named it after Friedel Hinz. It was found in an Husted sample in the Wümme River in Germany. It was also found in France, which means it's more than just a local thing in Germany. I also found it already in Flanders. So I think when you start looking at your frequentissimum populations in Italy, you might find also one of these new ones. Ecology, I'm sorry, as long as we keep calling this frequentissimum, we will not know what its correct ecology is. Probably it is more or less in the same, because the Wümme River is also not the cleanest river. This Hinsianum, if you look between here, Hinsianum and frequentissimum, look at the shape, look at the central area. Hinsianum always has this larger central axial and central area, which is not the case in frequentissimum. That is really a difference. Hinsianum is also a rare species. It's not a common species. Now, a species which is indeed common, and that we also know as frequentissimum, but as frequentissimum var minor, it's this one. It's Straubianum. We named it after François Straub, because François named it Rostrata var minor. How can you separate it? So these are the old materials that we have to dig through to find a solution. But what is typical, it's a very small, completely rounded species. It's an elliptical one. And if you look at the apices, it's always broadly rounded. It's never protracted. It's always broadly rounded. Look at the valves with the rave, always broadly rounded. With even, you can even say it has weakly convex, even parallel sides. But at the top, there is nothing. There is no protraction. It's not pointy. It's broadly rounded. Okay, this is again material from François Straub, Lac de Taillère in Neuchâtel in Switzerland. This is a typical shape, you see, broadly rounded in its entire cell cycle. So the longer valves or the shorter valves always have the same. So its ecology is again confused, but I find it often in localities with a higher salinity. So in higher conductivity, more brackish conditions, I just had the sample where I found it together with valves like Basilaria paxillifera, Reucosphenia, so things with higher conductivities. I add one more species, and then I think we will have a short break. That is this one, extremely rare. We called it, we named it after its very short striae, because it has very curtistriato, it's very short striae, it's very small and very rare. I don't know if you will find it, in our, yeah, sorry, my neighbor comes, yeah. My neighbor was going to call me. So you will, I have never seen it out except for this type material, but maybe you have it in Italy, maybe it's somewhere in Europe, it will pops up at the dominant species, but I don't know. There is another, I thought I was finished, but there's a last one, and that is this one. And I found this in Europe. I found this, I think, in Sweden and also in Flanders. And this is called abbreviatum. But it's also the name robustius is used. And it was described as by Reimer from United States as a species with very short striae only on the side. And this is a population from Sweden. And as you can see, it is a rather large species. I write here, no markings in the axial area. What do I mean with that? If you look at the axial area, you don't see structures in there. It's flat, it's clean. It is large. Axial area and central area, it's very, very large. In the Rafe valve, it is pointy, not protracted. Remember, we had at the beginning this species called dubium, that always has protracted apices. This is the United States, where it was described from. This is the type material, and you can see that it has no real markings. Why do I say that? There's another one, sorry. Why do I say that? Because you will find in Europe often the name Planothidium robustius. But Planothidium robustius, as you can see in this one, I took the pictures from the Hustedt book. As you can see here, there are depressions in the middle. There are markings. That one was described from Asia. The one that we have in Europe have no markings. So we have to use the American species abbreviatum. So in Europe, you have Planothidium abbreviatum. There's only one species, and that's called Pseudotannensis, but that is also, again, in Stockholm in the collection. I cannot check it. And the only thing we know from it is these two drawings. Now try to identify a species with these two drawings. That's not possible. So this is why we believe in Europe it is abbreviatum. This is, I put here dubium because the Rafe valve shows some similarity, but of course abbreviatum has a cavum, dubium has a sinus. The apices are not protracted, and this one has a large axial area. This one has a very narrow one. And also the number of striae. It should not be 120. I will check what it is, but it's a mistake, okay? This should be probably 14 or 15, but not 120. I have no idea what happened there. You cannot have 120 striae, of course, in Planothidium. Ecology of abbreviata is soft water rivers, oligotrophic, but needs to be determined for Europe. North American taxon that you will not have in Europe, but I just show you that we have it. And look, this looks like the unknown one that I have from Sweden, except this one has a cavum and the one from Sweden has a sinus. Unfortunately, there is no material left, so I cannot check what Mr. Sovereign has been seen. And then there's another one that I found on the website of North American diatoms. It's apiculatum, but again, it has a cavum and not a sinus. Why do I tell you these? It's just to be careful not to use these names. Okay, you don't find them in Europe. What you can find in Europe is this one. It's a very rare one. It's Planothidium ursacense. I think you have this probably in the Alps. You might find this. But it's a rare species. And I think it's time for another break and a round of questions. If you have questions, please ask them. And otherwise, we can take 5 to 10 minutes break.
Bart?
Tell me.
I have a comment more than a question.
Yes.
Because I found Planothidium incuriatum for the first time this year in a rice field.
Okay.
So very harsh environment, and with tolerant species like Navicula veneta, Sellafora nigri.
Okay.
Yeah. So probably it has a broader ecological range.
Yeah, that is the problem with all these recently separated species. As long as we only have the old data, but as long as the species were not described, you cannot use the data. And so we have to establish piece by piece the ecology. And actually that is, I think, more like your work in separating all these species with their ecology, because my work is finished and Carlos's work is finished. We offer you what is there. So it's all you environmental analysts that have to establish and refine it. And the best would be that if you find some of these species that have not a well-defined ecology, that you share what else is in there and what ecology, what physical chemistry had these samples. And that is the only way how we can improve our monitoring systems.
Yeah, we hope we are going to publish something.
Okay, good.
A curiosity, Bart, the presence of sinus, of the cavum, has ecological functionality, so is present for something in the ecology?
Yes, it's I was on the meeting. It was, I think, in the meeting in Japan in August, that somebody was saying that it has something to do with the attachment of the valves. But I don't remember very well, but it has a function. And I thought it had to do, I think the person said, I have to check it, but it has to do something with how the valves got attached.
Okay, thank you. It's strange, it's very particular structure, no, for a diatom.
Yeah, and it's developed in so many species that it must have a reason, because otherwise nature is not going to invent something that has no meaning.
Yes, of course. Thank you. Altre domande? In chat non vedo. So maybe it's time to stop other 5 minutes.
Yeah, let's make 5, 10 minutes.
Also 10 if you want, Bart.
Yes.
Yes, also 10 minutes if you want.
Yeah.
Yes.
No, 5 minutes is all. Let's meet again in 11:50. That's 6 minutes.
Perfect.
Okay, we can make another tea.
Okay.
Good. Perfect.
Super. Thank you. Okay, Bart, if you are ready, we are ready.
Yeah, right. So, apart from the groups with sinus and the groups with cavum, you also have within Planothidium a huge group of species that has not a cavum and not a sinus. So that means that if you look on the reflex valve, you see striae on both sides. I made two groups. The first is the larger group, that is with Planothidium delicatulum group. The other group are a bunch of 6-7 smaller species that we will do afterwards. Here, there are very important changes that we made the past years. The first species is delicatulum. I'm sorry, these are the best pictures I could find of the type material of delicatulum. And it's possible that in Europe, it's more than one species, but we are not sure at the moment. This is how the species was described. This is the drawing that you get from Kutzing, and he described it from brackish water, from an island on the north side of Germany, Wangerooge. We have the material in our lab. The only problem is that it was conserved with a very sticky, I have no idea what. And the best picture I could make of it is what you can see here. So I will use some material from other Swedish rivers to describe a little bit that species. So what do we see? We see a species which is actually rhombic in shape, with striae on both sides, and these striae go almost all the way to the middle. So there is no real central area, but in some of these valves, and I can show it here, I can show it there, and I can show it there. In some of these reflex valves, you see that the two middle striae are a little bit separated from each other. And there are populations where it is better to see than where there is not. You will see some other pictures later. The ray valve is also very typical in that the striae around the middle are radiated like a star. They look, here is, if you take this spot here where the red dot is now in the middle, you see that these striae are radiating to all the sides. And they stay radiate all across the whole cell cycle. What is also important to notice is that this species always has cone-shaped, so a pyramid-shaped tops. And the stops are separated from the rest of the valve. I will tell you why this is important in a minute. So this is what Horst put as delicatulum in his green book. So in the new freshwater, in the new Süßwasserflora, new freshwater flora. These are populations from Brittany, from Brittany in France. And as you can see, this white spot here is where the big separation is between the middle striae. You can see it here too. Here the striae are a little bit more separated than the others. Again, a population from Burgundy in eastern France. This is the population that you can find on the website of diatoms of the United States. This is a population also found in Brittany, and you can see always very nice. You have this separation. Also in the electron microscope, you see this separation, both on the inside, you can see it, as on the outside. Now, this is a species that is typical for brackish, slightly polluted, but higher trophic levels, but usually brackish waters. Could be inland saline waters, but also mostly on the coast side. So if you go to coastal areas, you will find often this species. Now, there has been a lot of confusion about this species because Horst once decided that the type material is no longer there and he will make a neotype. So he takes another population and he says, this is now the original material. And this is what the species was going to be. But this species was described as Planothidium galaicum by our colleagues from Spain, by the Blanco colleagues from Spain. And this is different from what Horst designed as being, this is different from what is Delicatulum. Look, it's a more slender species. It's lanceolate. It's not rhombic lanceolate, it's lanceolate. And it has only very weakly protracted, cone-shaped cuneate apices. If you look on the Wraith view, look at the striae. They are what they call geniculated. They make this knee-shaped. See, they start and they curve a little bit, but they are not straight. Here you can see it very well. It's like when you bend your knee, when you bend your knee, you have a knick in the direction of the striae. Very typically, but you cannot see this in the light microscope, this species has small dots, small silica points, we call it silica papillae, on this material. This is the material that Horst used as the neotype, which is a Van Herk slide, but it's absolutely nothing to do with Delicatula. It is also a typical fresh brackish, and even marine species. So you will find it again in those areas where you have more chloride and sulfate and so on, so higher conductivities. A last species in this group, and that is a very, very, very important one because it has been so many times misidentified, is Planothidium haukianum. And then I think if I ask you, did you find already haukianum? People that work in coastal sites probably have found this. Please forget this, okay? It's not correct. This is haukianum. And this is Haukianum sensu Hustedt. And what is typical, Hustedt made a very elliptic, roundish species. Now, Horst has done again also a work on this, and he found the type material, and what we can see immediately that this species is almost everything except round. And what is typical is that it has very thick striae, and on one side there's always a stria missing. Look here, look there. We were lucky, I was lucky, to find the type material in Vienna, and together with my colleagues from Croatia and Luc, we described this, we studied this species, and it's a very thin, long species with very broad striae and always a very clear gap in the middle. Now, this species is very typical. You can see it here again. This species is very typical for karstic freshwater habitats. So it's absolutely wrong to identify this in brackish and marine waters because it has nothing to do. And everywhere in the world, you find this species to be brackish and marine. This is not correct. These are all different species. Okay. If you look on the ray valve, you will also find a gap in one side. I should have turned this one. A gap, a gap, a gap, a gap, a gap. Everywhere, even in the smaller ones, there's always a gap in the middle. This is also this type material. And you can see always here and there and there and there and there, this gap in the middle. Now, Horst has put this in his book on the Planothidium haukianum. I agree with what he wrote there, but it is not a species that is brackish. It is freshwater, oligotrophic, chalk-rich, so these karstic areas, and I believe it's possibly only even present around the Adriatic Sea. So you in Italy might find it, but only in these karstic spring areas. So if you have karstic spring areas, you probably will find it. But if you find it in marine circumstances or in large estuaries, people working in Venice, and you find it in the canals in Venice, no, it cannot be. It's a different species. There are some more species in this group that I didn't mention because they are extremely rare. One of them is this one that I found in Sweden, in brackish water in Sweden. It was described by Kleve as Planothidium, as Agnanthes dispar. It's Planothidium dispar. I just mention it because you might not have it, but if you find something large that looks like a Planothidium delicatulum with a big gap and some small heads, you know where to find. And another one, and I found it in the same material as Kutzing found, it's this one, and it was described by Hustedt as Agnanthes linkei. And it was described, and if you find in this sample, you see it's a large delicatulum type species, but look, it has very pointy heads. But always this gap, and Hustedt also has shown this gap. So this is Planothidium linkei. Very rare taxon, but I find it from time to time also in Flanders. And another one that I found in Flanders is this one. And it was described also by Hustedt as Agnanthes delicatula var robusta. And it's now Planothidium robustum, and you can have this also in Europe, but this is a freshwater species. But you can see it's very nicely pointy heads, no gap in the middle, and very radiate, almost not shortened striae, and that is exactly what Hustedt also has been drawing. So this is probably also a species you might find in Italy. I'm always surprised what you can find in all these nice oligotrophic rivers that you have in Italy. I look forward to the intercalibration next year because we are also going to see a lot of nice species. Now, there's also a group of smaller species without sinus and without cavum. And I'm sorry, but that's a problem. And that's the problem of Planothidium dowi versus Planothidium granum, with granum being the older name and dowi the younger name. And if you see them like this, you say, why is he making a problem? This one has big heads, this one has small heads. Yeah, you're right. I just like to make problems where there aren't. No, there is a problem. Let's look at Dowie. Dowie was described by Vogt, and this is not the type material because I didn't find the type material. It's described from a river in Belgium, and you have a small, nicely rounded central part and two nicely round heads on both sides. So compact species, very small, and the whole population looks almost like that. Sometimes it can be a little bit shorter, the apices, sometimes a little bit more capitate, like this one, or like that one, or like that one. Horst has it in his booklet as Planothidium Dowie. Other people find it, but it starts to show some smaller valves where the heads are gone. So you have longer ones with heads, and as soon as they become smaller, the heads start to disappear. Look, long heads, shorter heads. This is a population that Eduardo Morales, the late Eduardo Morales, found. And it was found everywhere in Northern Hemisphere. But suddenly, Lange Berthelot writes, actually, we have no idea what the ecology is because it is confused with Planothidium granum. Now, let's have a look at this granum. But first one that you can confuse it with, it's Planothidium minutissimum. I will talk about this later. It's also a small one. It's also a Planothidium one with always a typical gap in the middle, but the one that has no heads. See, it's shortly protracted, but very, very shortly. Now, this is a Planothidium population that starts as a Dowie and ends at a granum. So you actually have a continuum from the real Dowie towards the real granum, both in Rave valve as in Raveless valve. Now there's only one problem. The type material of granum, it's a North American species, is lost. And I'm waiting that Paul Hamilton one day passes there to take the sample. The only problem is it's a 7-hour drive from his house. That means a 14-hour drive to go to the original place where granum was sampled. So what we probably will have to do is we will have to designate a neotype. But I didn't find the time yet to look at all North American populations to find the time. So granum at the moment is the Dowie without heads. So these I would call granum. And the ones with the heads, the nice capitate heads, I will call Dowie. But Horst, oh, I put the wrong one. This is not, this should be granum. 58, which plate is it? I'll check for you if it's, what is it called? Yeah, I think it should be, that's the wrong one. I have to correct this. But so this is granum according to Horst. But if you put them together, I don't see the difference anymore. So this is Morales who put also this as granum and probably only present in Canada. But what to do with all the ones that you find in Europe? So I would say, I would suggest, oh, I'll go back here, call the ones with the heads. You can call them Dowie. The ones without the heads, you can call them granum. But if you find a population like this, I don't know. I have no idea. Probably what I will do is I'm going to look to try to find the type material from Dowie again in Copenhagen from Vogt. And if I find that, make a big study of a huge population of Dowie. And if it's the same as granum, just get rid of the Dowie name. But at the moment, you can keep them separate, but I think they might have the same ecology. Now, the last group that we have to discuss today is this one. Small species, no cavum, no sinus, and it's a species that I call also the Engelbrechti problem. A lot of you probably will have found Planothidium engelbrechtii. The only problem is that you use this book for engelbrechtii, as everybody did. Now, the real engelbrechtii was described by Shonnoki from South Africa, from the Jackal River. That is the real engelbrechtii. And that is the real description. So together with Pierre Compère, my predecessor, we got the material from the Shonnoki collection and we studied the type. And this is how the real engelbrechtii looks like. It's a slightly rhombic lanceolate species. Striae are very long. There is no central area. You can find sometimes on the secondary side here and there an extra striae that is put in, but actually there's no real central area. 17 to 18 striae. And what is typical, it's a little bit inflated in the middle, but it always has this long protracted ends. This is what we see in the electron microscope, and that becomes very important because that is how you can separate. That's of course not for you, but how we can separate the European ones from the South African ones. At the same time, Carter describes from a small island named Tristan da Cunha in the Atlantic Ocean, describes again the same species under the name of Pericavum. And it's a name you can also find in European literature. And I think Pericavum, based on what we discovered, is exactly the same, because I have a lot of material from Tristan da Cunha, the same as engelbrechtii. So engelbrechtii and Pericavum is the same. But then I start to, when I was visiting Sicily for orchids a couple of years ago, I took some samples from Monte Lauro and I found this species. And this has some differences with engelbrechtii and Pericavum. I thought first, oh, nice, I have Pericavum also in Sicily. But I think it's a separate species that needs to be described as a new one. Because I also found it in Flanders, but in Flanders, it has a small gap in the middle, which I did not find, or that not that obvious in the Sicilian one. So I have now two populations from Europe, one from Sicily and one from Flanders, that are not engelbrechtii and not Pericavum, and that are waiting for a description. And if you find one of these in Italy, it would be very nice to know about this and under what circumstances you find it. And if you have large populations, and we can always describe this together. I was hoping this year, I wanted to go back to Sicily and take more samples. We were back in Sicily on the Monte Lauro, but it has been so dry, and all the small pools that I sampled 8 years ago were already dry, and I could not find more material. So I could not take another sample. That was a big disappointment. So if some of you lives in Sicily and passes Monte Lauro when it's wet, please take samples for me from these small pools, because then we can have a better idea about what this species is. So at the moment, I would call them engelbrechtii from Sicily and engelbrechtii from Flanders, but know that these are not the real engelbrechtii. There's one that is more or less similar. It's a brackish species. It was described by Sal Blanco as Planothidium lacustre. It's very small with high striae density, and it has very typical inflated central part and long rostrate apices. I have never seen this in my life. It's probably only in Spain or something. I think it's from the Ebro. But if you find it, this is a brackish species. One of the last ones that we need to discuss is a species you find in polluted rivers, and it's called Planothidium minutissimum. Very small and very typical. It was described by Kaske. And it has, look here, always a small gap in the middle. Always a small gap in the middle. And it's a rhombic species with always a gap in the middle. So this is very, 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 very typical for this one. I never find large populations, but you can find it from time to time. Also, hey, Horst has it again. Hey, see, always with this gap in the middle. I have my doubts about this one. Maybe this is the wrong picture. Oh, I realized this is Delicatulum. So please correct. I need to correct this in my slide. This is Delicatulum. This is the wrong picture. I took the wrong one. These ones are okay. And you see always in the middle, a gap. It's very, very, very typical. Always in the middle, a gap. Very obvious species. Same, Eduardo found it also in United States, and here you can really see this gap. But it has no sinus. So if you look on the inside, there's no thumbprint, no fingerprint on the in the inside. It is found, horse rides often quite abundant. I always find it quite rare, but maybe I don't have the right samples for it. And it's always found in higher trophic levels. It can be confused with Engelbrechtii, and I think that it has often been identified as Engelbrechtii. But be careful, Engelbrechtii always has a continuous striation pattern, very regular, whereas this one always have a gap. And then there are some few smaller ones that I want to add, always probably in brackish waters. One is Planothidium pumilum, very small regular species. Another one, you can confuse it with Engelbrechtii, but look at the size. It's actually very difficult because the width is the same, but the length is very short. And then there is this Verumianum, also a very small roundish one, also described from brackish conditions in the central, in the Baltic area. I'm not sure if you find it in Italy. We have a population like that we found in France, and we believe this is this Verumianum, also with Engelbrechtii, very small and rounded. And then there is one that I start to find more often, and it was described by from Germany, and it's called Planothidium van Herkii. It was actually described as a Reucosphenia, and if you look at the girdle views, you know why people think this might have been a Reucosphenia. I find this quite often in brackish conditions, and when present, it always has the same shape, rhombic, with a large axial central area and very small. It was described as Planothidium rhombiculum, but forget that name because that is a synonym as from Van Herkii. Van Herkii has the priority. So this has priority over this one. You see, difference with Engelbrechtii. This is again one of these species that I have the feeling people identified it as Engelbrechtii because in the little green book that Horst made, the old Süßwasserflora, it was all called Engelbrechtii. See, another one from this is from more saline conditions in Burgundy, also Van Herkii. You can confuse it with Granum, but Granum never has an axial area that is very large, whereas Rhombiculum, it was still Rhombiculum here, it should now be Van Herkii, of course, has this gap in the middle. Another species, freshwater, but mainly probably Baltic area, not Southern Europe, is Planothidium lemmermanii, very rare species. I have never seen it in my life myself. And then to close this workshop, there are two genera that have recently been split off from Planothidium. One is Skabichevskia, and the other one is Glivixia. Why do I name these? Because you know these species. This is a species in oligotrophic conditions, probably more Scandinavian than Southern Europe, but it was described as Agnanthes calcar, and sometimes you even find the name Planothidium calcar, which I don't think is a valid name, but this is Glivixia. What is the strange thing about the genus Glivixia? It has this cavum, not only on the raveless valve, but also on the ray valve. You see, it also has this structure on the ray valve. Another one, and then we go to the genus Skabichevskia, sometimes known as Agnanthes oestrupi or Planothidium oestrupi, is this one. But the ray valve has a totally different structure and has nothing to do with the Planothidium. The same as something you know as Agnanthes paragalli. And this is now Skabichevskia paragaloi, or you know this probably as Planothidium paragaloi. But the correct name should be Skabichevskia paragaloi. And I think I put some interesting literature there, and there are some more interesting papers. And these are all the people I need to thank. And I think I need to thank you for having me on this workshop. And I think we can close it here. So it's a lot. I know there's a lot of species, and you probably heard today a lot of names and a lot of species you've never heard of before. And I think it will not be that easy at the beginning to separate all your species, but I think it will be very useful to start looking at what species you have in Italy. And I'm sure you will probably end up with a species that you haven't seen in my workshop, and probably with species that we still have to separate, because we only based our material on Northern Europe and Central Europe material. So we didn't work with Italian or Southern Europe material. But so now I think it's up to you to start working on it. And if you have still questions about the last part or about the whole part, question is, can the small species without sinus and cavum be confused with Agnanthidium? Maybe yes, but I don't. But Agnanthidium species always have a much finer striation pattern. The striae are much finer because they are made of small dots and not about these large areolae. I think if there are some species with what you can confuse them with, then I would say it's species like Platessa conspicua, Agnanthes conspicua. These species you can confuse with, or Platessa oblongella, but we also sometimes use Karayevia oblongella. You can confuse with these. But of course, if you then look at the other valve with Platessa oblongella, it's absolutely not possible. And conspicua, yeah, it has a different ultrastructure, and the striae in conspicua are more separated. So I think it's more confusing with Platessa than with Agnanthidium.
Hi, Bart.
Hi.
Thank you for your nice presentation. It was very, very interesting. I'm wondering if we learned now that it's very, very difficult to distinguish the rave valves. And so at the moment in our method, it's considered that we have to count it twice when we see the waveless valve. and don't consider the rave valve. Shall we continue to make this kind of counting?
I always, well, my idea is always count one single valve. I know that, for instance, the Germans, you had to call, and you have to count entities, and whether it's one frustal with two valves or one valve, it was always counted as one. So that was also a mistake. They changed that already. If that's your method, I would say keep the method as it is. But what you should do amongst your group is try the two methods. Try one method where you distinguish one for one valve, or the thing is always count immediately two and don't count the rave valves, and see if there are differences in the results, because it's not because we want it taxonomically completely correct that it should also be practically correct. If it's easier to only use the raveless valves and not count the rave valves, then yeah, don't use it. I would always try to count to make the separation between rave and raveless valves. And what is true is that Planothidiums, there are a few exceptions, but the Planothidiums, they usually come in bulk. That means you'll have one or two species in your sample, but you will never have 7 species that look very similar in your sample. Okay, Lanceolatum and Frequentissimum, yes, you can find them together. But for instance, you will not have N. alexandra, N. Gallicum, N. amphibium, N. incuriatum, and so on and so on and so on, together in one sample. So if you have rave valves, you usually can have a look at the raveless valves and you find out what your population is. And you do the same with Coconeus, count only raveless valves and add the rave valves to one of the Coconeus that you find. I would do it like that and not count double. If you have one rave valve, one raveless valve, say immediately 2, count 1, and then see afterwards what you have on rave valves and distribute over the different raveless valves. I would do it like that, and I think proportionally it might be better, but yeah, try the different systems. I'm not going to change your system, so keep your system as it is, but maybe one day you find it more useful to change it, and then is the time to start thinking about it.
Okay, thank you.
You're welcome. More questions? Nope. Then I think I hope to see you all next year in Terni.
Yes, a lot of us will be there. Yes, Bart.
I looked briefly at the slides already. I think there are some Planothidiums in there, so we can continue the discussion.
To the discussion in presence, yes.
Yeah.
No, so thank you, Bart, very much for the very interesting presentation. You are always very clear also, maybe for us, for English, because your explanation, you're always so clear.
Perfect English, Bart.
Yes. And so we have a lot of new things about Planothidium, so we can look at them in another way now.
I think most of the species you will not have.
Yes, of course.
But it's important to realize that some changes you probably will have to make. The incuriatum, amphibium, the gallicum, you probably will have gallicum also in Italy. I start to see it more often. Also in these smaller ones that you find in brackish conditions, it might be interesting to have a look what you have. This Van Herkii, I think you might find it. I think you might find it, yeah. So
if there is any question more, there is a lot of thank you, Bart, in the chat.
And if you ever have questions, always send me an email. You can send me an email, and then I can try to answer. But if you send me one picture of a valve, I'm afraid I'm gonna say it's a nice diatom, and I can say it's a Planothidium, and then I think that's about it, because it's very difficult to do this with one valve. So if you have questions about what is this, send me at least 10 pictures, because then I can have an idea about the variability.
Ok, thank you Bart, e grazie a tutti anche di aver partecipato. Insomma, è stato bello aver visto così tanta gente partecipare anche a questo workshop.
Probabilmente metteremo la registrazione dell'incontro sul sito tra qualche giorno. Adesso vediamo se riusciamo con questa modalità della riunione, ma penso di sì. Perché qualcuno l'ha chiesto, me l'aveva chiesto anche via mail,
Quindi per chi partecipa all'interconfronto, buona conta.
Esatto, vi rivedremo tutti lì. Non spaventatevi.
I'm sorry, I hope I didn't cause too much confusion now with all these new names.
No.
I can tell this is an easy group. I'm now working on the Staurosira, Staurosirella, and Fragillaria groups. Yeah, a little bit more difficult. And I might even start this year one day. Okay.
Ok, thank you.
Ok.
Thank you very much.
Saluti a tutti.
Ciao, bye bye.
Ciao a tutti.
Ciao, grazie.
Saluti.
Grazie a tutti.
Ciao, grazie.